Here's our AP Physics Law of Reflection lecture. We have an incident ray coming into a mirror, hitting the mirror, bouncing off, and this is a reflected ray. This line here, this dotted line that we draw perpendicular to the surface, right at the point of reflection, is called the normal line, and we know that angle of incidence equals angle of reflection. So to review this, the incident ray comes in. This is a light ray coming in, hitting a mirror, bouncing off, and we have to draw a normal line in order to find out what the angle of incidence and the angle of reflection is. We always draw the we always find the angle of incidence between the normal line to the light ray, and angle of reflection is from the normal line to the light ray. Here's an example here about the law of reflection. We have a light ray coming in. It hits the mirror, and a normal line is drawn, and the angle of incidence equals the angle of reflection. Here we have an example of reflection off a smooth versus a rough surface. The law of reflection occurs in both cases. In this first case here, all the light rays come in parallel to each other and reflect off parallel to each other. In the second case, where the surface is rough, all the light rays come in parallel to each other and they reflect off at a variety of different angles, and so that's why the surface doesn't look shiny. We can't see ourselves in the surface. But for each point here, for each position, if you're to draw a normal line at that point of reflection, the angle of incidence would equal the angle of reflection. It's helpful to realize when we study reflection that your right hand is really the left hand of the image. The image inside the mirror is reversed, and so a right hand would be a left hand, and that's why they spell the word ambulance backwards on an ambulance. Is because when you look in the rearview mirror, you see the word ambulance in the correct direction. When we have a virtual image in a mirror, the image is going to be upright. The image is the same size as you are. The image is located as far behind the mirror as you are in front of it. So we have this chess piece here, and light rays coming off the chess piece hit the mirror, go into your eye, a normal line is drawn, angle of incidence equals angle of reflection, and our eyes perceive the chess piece right along this line. This is the apparent path of the light ray, and over here, this blue chess piece, we see a virtual image. This image distance from the mirror to the image is equal to the object distance, which is from the mirror to the object. Those two distances are the same. The size of the image looks like the same size as the object. The image distance equals the object distance. And the image is also upright, and this is called a virtual image. When a person looks in a mirror and they see their feet, the light rays come off of their feet, hit the mirror, and go to their eye. So really, this bottom part of the mirror from B down below to the floor, that part of the mirror is not necessary. You only need the mirror from point P up here, that's in between D and C, all the way down to B. It's half the size of the person. So what happens up on top here is the light rays from the top of the head come in, hit at point P, go to your eye. The light rays from the shoe come on up, hit at point B, go to your eye. So the only part of the mirror that you actually need is from point P, which is right about here, all the way down to point B, and that's half your size. So the major piece of information we need to come away with here is that the angle of incidence equals the angle of reflection, and this is called the law of reflection.